So without further ado, I'm going to go ahead and jump right into the presentation. So a little just kind of quick rundown about Simplify. Kind of as our motto, Simplify offers the safest, the most efficient, and the simplest way to use energy storage. We also look to optimize any power generation source, both on-grid or off-grid, in hopes of utilizing different sorts of generation, as well as offer a wide variety of product use. So currently, we're about 30 plus countries deployed in. You can kind of see the map here of where we actually are, and about 50 megawatt hours since 2010. This is one of the slides I tend to have to update a lot, so likely by now it has gone up from even there. As far as kind of the realms that we sit in, commercial and industrial, so everything from the C&I, the larger space stuff, emergency response, huge one, definitely something we started in even, and definitely a lot with our all-in-one and smaller products. We do a lot of emergency response. Residential, still the biggest market around. Residential solar, or really any kind of renewable system, or even just a backup system. And off-grid power and security. Due to the way we manufacture our batteries, we've been huge in the off-grid market when it comes to securing down a good battery that you can utilize for off-grid power. So I'd just like to kind of lead off with a little bit about battery chemistry in general, and then kind of talk about what differentiates the lithium iron phosphate and Simplify batteries. So tons of different types of energy storage out there. I mean, lead acid, still probably the most widely used energy storage platform in the world. It's definitely, the tides are changing slowly, but I would say lead acid, especially with cars being around and using these lead acid batteries, this is the most used battery around, even in energy storage. There's some other different weird kind of chemistries you'll see. There's the saltwater battery for a while, the flow redux kind of batteries, and some maybe other weird off chemistries that you don't see a ton of. And then there's lithium ion, which lithium ion by far, I would say the largest growing battery right now. I would say eventually this will supplant lead acid battery as the main battery for pretty much all products. Within lithium ion, tons of different types of chemistries. You see here your Tesla, your LG Chem, and your Simplify battery. So it's important to kind of distinguish when it talks about lithium batteries. So here we can actually see, this is the chart that I love to use this chart. It actually shows these 5 different lithium ion chemistries and kind of a side-by-side comparison. So you can actually see what each one has to offer and different kind of specs here. So danger of thermal runaway. I kind of just like to talk off this slide since I don't have a slide specific to thermal runaway, but we all know what this is. This is, you see in your cell phones, you see in your laptops when it actually heats up and sometimes even catches on fire. Lithium iron phosphate here has no chance for thermal runaway. Nickel manganese cobalt, manganese oxide, nickel cobalt oxide, and cobalt oxide are all prone to that thermal runaway. You hear about this on the news all the time with the batteries catching fire. So all of these lithium ion chemistries are definitely prone to thermal runaway, whereas the lithium iron phosphate is not. It's also non-toxic. So it's the only one out of these chemistries that is that non-toxic and landfill safe chemistry. And due to a lot of this, we don't have ventilation requirements, you can see, we don't have cooling requirements, and it just tends to be a safer battery overall. So even after we've kind of chosen our lithium chemistry, we still need a form factor to hold that chemistry. These are probably the main form factors that are used today: the cylindrical cell, the pouch cell, and the prismatic cell. So these are what actually hold that lithium chemistry in and are kind of the building blocks that we build a battery upon. So the pouch cell tends to be really lightweight, flexible. You see these in laptops all the time. This is probably the most common use of it is the laptop. The issues with it, swelling, they're very small in capacity. And even if you look here, positive and negative are just these tabs. So oftentimes when you put a lot of them together, you're going to get some short circuit. The prismatic cell, not used that often anymore. Sometimes you still see these though. They're very blocky. They're kind of tough to get into spaces just because of the nature of like how it's actually built and how you have to connect the positive and negatives often with bus bars. So they kind of don't leave a ton of room when it comes to battery design. They're also pretty expensive to produce. So oftentimes if you're buying a battery that has a prismatic cell in it, you can expect that it's going to be a little bit more on the expensive side. And then the cylindrical cell. So, I mean, think AA battery. That's the easiest way to describe a cylindrical cell. Most commonly used battery due to that, and definitely it's a great way to build out large batteries or even small batteries that are scalable. So the cylindrical cell actually has built-in short circuit protection due to where the negative and the positive are, and the way that it's all wound up, if it's done right, you're going to see some really high cycle life out of these cylindrical cells. So I've kind of given it away already, but Simplified Power utilizes a lithium iron phosphate chemistry, and we use a cylindrical form factor to build out these batteries. So the advantages when we use that, and these are actually warranted parameters here, the operating and charging temperature, very, very wide range here. So -4 to 140 for the operating temperature, and then 32 degrees Fahrenheit to 120 degrees Fahrenheit for the charging temperature. So this allows us to utilize these batteries in hotter climates with areas that maybe we have to put in a box with no ventilation. We don't need HVAC. We don't need a liquid coolant system, and they can definitely handle the heat. Another thing that's worth noting here is that if you were talking about a lead acid battery within this charging temperature or the operating temperature, you'd see inefficiencies on the high and low end. Simply just does not happen with the lithium iron phosphate. The efficiencies are so minimal that they're not even notable when it comes to even operating at these higher temperatures. So each of our simplified batteries also comes with the integrated battery management system. So each battery has an internal battery management system, or BMS. This handles an assortment of things. The most notable of those is protection. So the BMS is really there as an internal source for each battery to really provide that protection. So charge and discharge protection, short circuit protection, and overcurrent protection. The great part about the battery management system built into all of the simplified batteries is it'll actually disconnect if it sees something it does not like, in hopes of preventing any damage. So if it sees maybe overcurrent, it actually has the ability to open circuit and disconnect the battery from whatever is charging or discharging it. The other feature of the battery management system is cell balancing. So oftentimes when we're paralleling a lot of these batteries, each battery management system does not work with each other, so they're independent. So within them, they'll actually balance out the battery with the cells that are within each pack. This keeps the entire bank balanced out, as well as the individual batteries. And just to be clear, this is a passive cell balancing. So it happens on the top end of things. So some other key features here about the simplified batteries and really all of our products, power capacity. So fast and adaptable charge and discharge. So that's a rating of C/2. So what is a C rating? A C rating is just a measure of the rate at which a battery is discharged or charged relative to its maximum capacity. So the example I like to use, at 1C, we're discharging the entire battery's capacity, in a 1 hour window. So we're talking about a 3,500 watt hour battery. We would discharge 3,500 watt hours in 1 hour. The C/2, which is what we utilize and what we warranty in the simplified batteries, means you can discharge the entire capacity in a 2 hour window. So in this case, you could discharge a 3,500 watt hour battery, 1,750 watts per hour for 2 hours. So 2 hours, you could discharge the entire battery. This also works as far as charging goes. So if you have a situation where you need to charge fast, you can charge in that 2 hour window. If you have, let's say, some heavier loads like a well pump or an air conditioner, we could actually have a smaller battery bank that can handle these heavier loads. So unlike maybe a traditional lead acid system where you need a large bank to cover those heavier power demands, with the simplified battery and with lithium iron phosphate, due to its ability to charge or discharge fast, we can actually cover those heavier loads with less batteries. Scalability and expandability, this one's huge. So when it comes to scaling, there really is no limit as far as scalability on these smaller, simplified 3.5 and 2.7 batteries. The power electronics, maybe you're going to hit a point where you cannot add any more inverters or chargers, but as far as the battery is concerned, we can go ahead and just parallel as many as we want. It's a simple parallel connection. There's no communication lines, as I mentioned, from BMS to BMS. It's just a simple connecting of the batteries. Expandability, another huge one, and that's the ability to actually add more battery capacity after the fact. So, example of that, you can see the system on the left here in 2013 had 8 simplified batteries, 20.8 kilowatt hours total. And then over here in 2015, so 2 years later, they were able to expand the system, the same system, and add actually double down to 41.6 kilowatt hours. So we allow for the systems to be expanded on, no problem. This is definitely great when it comes to, just to kind of take a step back here, it's great when it comes to customer peace of mind, or even installer peace of mind when it comes to sizing systems, whether it's off-grid, on-grid. You know that you can always add power, or there's room for expansion later. The lithium iron phosphate simplified batteries are also maintenance free. So there's no off-gassing, there's no specific gravity checks, anything like that. They virtually have zero maintenance. Very low self-discharge rate, so about less than 1% per month. So this means that they're very good at idling. So if you're using the system for a grid-tied battery backup, it's awesome. You can just use it. You can let it hold that charge really, really well until you absolutely need it. And that's why they're really ideal in those backup situations. It also helps if you have a system that maybe is sitting in place for a little while before the installation happens, they won't lose their charge. So these batteries and our kind of original renewable energy products were all stemmed from the idea of a drop-in lead acid replacement. This is a kind of just a quick picture of showing, we have this large bank of lead acid batteries, and we can really cut down the size by putting in the lithium iron phosphate here, and really minimize how many batteries and the actual connections we need for a cleaner, easier system, less maintenance. So as far as warranty goes on all our batteries, it's important to kind of see how that ties to depth of discharge or how much you're actually using the battery. So at 80% depth of discharge, we warranty 10,000 cycles. At 90% depth of discharge, we warranty 5,000 cycles. And at 100% depth of discharge, we warranty 3,500 cycles. We also refer to end of life. So this is a warranty term, EOL. So the capacity at that warranted period to be at least 80% of the original capacity. This is definitely a lot higher than you'll see a lot of the competitors. And we definitely stand behind that this product's going to continue to work even after it hits that warranty period. So just kind of a quick overview of our current products before we go into some of the newer stuff later on. The 24 volt and the 48 volt, 2.7 and 3.5, still the staple products. We utilize them in a lot of our all-in-ones as well. The 2.7 comes in 105 amp hours at 24 volts and 52 amp hours at 48 volts. The 3.5 comes in 138 amp hours at 24 volts and 69 amp hours at 48 volts. These are easy to use, the most simple kind of lithium battery you could design. No communication cables, just a simple, easy to use battery. On grid, off grid, tons of different applications with these. The access unit, this is definitely our most popular all-in-one right now. These are plug-and-play units. They're built with the inverter charger built into them. We can use them DC or AC coupled. They're NEMA 3R, so they're outdoor ready. They can sit right outside. There's no maintenance, and they come in a few different variations that we'll go into later. So real quick before we jump into kind of the more nitty-gritty stuff about the different new products and things like that, the levelized cost of energy, I wanted to kind of discuss. So if you are maybe an installer or selling the product, it's important to kind of note how, or even just a customer, to know how to use this levelized cost of energy when comparing batteries. So what is the levelized cost of energy? It's really just seeing how much, seeing the cost over time of the battery. So we don't just factor in the upfront cost, but we really factor in the cost when we're looking at how much we get out of the battery storage-wise, as well as what the warranty actually has to offer. So the formula we actually use for that is this. MSRP, or price, depending on if you have the ability to see different prices side by side, maybe by a distributor or whatever it is, over the capacity. So in the case of the 3.5, we would go ahead and use 3.5 kilowatt hours here. Cycles, so the cycles warranted, the efficiency rate, and the depth of discharge used. We can also add in ancillary costs. So oftentimes you might have some costs that are specifically tied to the installation. So maybe it's driving a truck on site, maybe it's, certain materials are needed for a certain battery. So those can always be added in as well. So this is an example of that, using the 3.5 kilowatt hour battery and a lithium competitor that I will keep nameless, but this competitor happened to be a lot less expensive up front than the Simplify battery. But after we actually plugged in the numbers, so we see the cost times the capacity times the desired depth of discharge. In this case, we're using 90%. The efficiency at 98%, and the cycles. So we know 90% depth of discharge is warranty for 5,000 cycles. Then we get an overall cost of 20 cents per kilowatt hour. Even though this battery was actually cheaper up front, it came out higher at 25 cents per kilowatt hour. That has a lot to do with the way it's warranted and what you can actually pull out of that battery. So definitely something to consider when looking at batteries side by side is this levelized cost of energy. It really can help tie things in when we're talking about a complete system, and you can really add it to your return on investment as well. So speaking of total systems, just a little bit about using our products with solar and actually utilizing these simplified batteries with the solar systems. Tons of different options here. AC coupled, this is forever becoming more and more popular, and actually tying to existing PV, or even just using grid-tied inverters with a battery-based inverter tied into it. So the idea here is you already have your existing PV array, so your grid-tied PV coming in, and you're kind of putting a stop right here with a battery-based inverter in order to charge your batteries. This allows for us to disconnect when the grid goes down, bring back online that PV and actually cover those dedicated loads. So it's we can design some really cool backup systems, as well as we can utilize that power during the day. So AC coupling with the Access couldn't be any more simple. It's outdoor rated, which is great for customers. You don't even have to put it inside. They'll never even have to deal with it if they don't want to. It's easy to install. All we're really doing is just running that existing PV in and running the AC output. There's really a lot less materials and system design that goes into it. So that is our Schneider Access. The Schneider Access is the one that we AC couple. DC coupling, still popular and definitely can still be utilized on or off grid. And that would be using charge controllers. So you're not actually inverting from the PV. You're simply just putting it at a voltage and amperage that the battery wants to see in order to invert it back out into the loads, both main loads panel and dedicated loads panel. So same functionality though, in the sense that if the grid goes down, we can actually disconnect here and just cover what's on those critical load panel, while also still being able to charge DC. So we can actually do DC coupled as well with our Access unit, especially if you're in California. We do have one that's DC coupled and Rule 21 compliant. So we can, here's just a quick example. This is all within the Access. So really all that you're doing is simply connecting the PV in and the AC outs. And that's the entire installation virtually. So just to kind of reiterate, what's the key benefits of adding a battery system to your PV array? Definitely it's going to be system functionality when it comes to these multi-mode inverters. They just tend to have more functionality. They can do a lot more different features like peak load shaving, time of use, and you can really utilize that energy storage. Energy security, this one's huge. We're talking backup storage when you need it if the grid goes down, utilizing the grid-tied PV inverters that are already in place if you're talking about an existing PV system. And then some more advanced features, as I just said. So that's like the cell, the time of use, or even the peak load shaving. It can all be done from those battery-based inverters and having that storage on the other end. And we can also utilize that daytime PV production. This one I hear a lot. Somebody maybe they feel that they're wasting their PV production in the day by just selling it back if they're not getting a good rate. Now they can store it and either use it for their loads when they get home, or even I've seen things like charging a car from that PV production when you get home. So tons of different key benefits there. Really is the added benefit of that battery to that solar system. So just a quick little bit about kind of our batteries and how they're installed and how they look when they're installed. Here's kind of just an overall picture of what they look like when they're mounted up. Tons of different options when it comes to mounting. We really don't have clearance requirements or orientation requirements. So we don't require that you use these brackets. You could use battery box. You could have them all right up against each other. Tons of different options to kind of get creative on how to size up these systems. And it's definitely going to depend a lot on the size of the system. So in this case, this is a fairly large system. They're utilizing a lot of wall space, so it made a lot of sense here to go ahead and just tie everything onto these brackets with these really clean trays. The technique that we actually utilize at Simplify for paralleling batteries is a bit different. So what we would expect for a lead acid battery is that positive to positive, positive to positive connection, possibly up to a bus bar, where when we're talking about the Simplify battery, what we expect is same length, same gauge wire, all going to a common bus. What's the reason for this? Well, a few different things. It definitely allows for the distribution of power when we're charging to go evenly into each battery, help with keeping everything in balance, as well as the discharge. So when we're discharging the battery, everything stays in balance as well. If you utilize this technique, you can definitely scale up to these huge systems utilizing these small 48-volt batteries, and we can definitely see that higher efficiency out of them. So a little bit about our access. We just unveiled our new access that we'll talk about, as well as our current access offerings. So these utilize the 3.5 kilowatt hour batteries. They're 48 volt batteries. Again, it comes with the inverter charger built in. It's pre-wired. It's pre-programmed. Comes in an NEMA 3R outdoor rated enclosure, and it's really designed for just a quick, easy installation. So if we were to compare that to maybe, let's say, putting together all the parts and pieces ourselves, why utilize this? Well, when we're talking about, putting all the parts and pieces together ourselves, we're talking about longer design time, typically indoor rated, might take multiple days to actually do the installation, and a lot of programming and setting up those communications between devices. We've done all of that for you in the access. It's already ready to go. It's pre-wired, and you won't have to do all of that assembling. It's already pre-assembled out of the factory. So these are actually the two units we're offering. So the Schneider access is kind of the base. That was what we started with, and this unit's awesome. It can do a bunch of different functions, and then this one can actually be AC coupled as well as DC coupled, as well as our newer one, which is the Outback access. And I can kind of walk you through what parts and pieces we're using in those. So in the Schneider, we utilize this inverter charger. It's the 6848 XW Plus. So this is a 6.8 kilowatts continuous battery-based multi-mode inverter. Has a max surge capacity of 12 kilowatts and 140 amps DC charger built into it. So that could be for utilizing things like AC sources such as grid or generator to charge the batteries. You also have the option here to go DC coupled on this one. So it comes standard. You could just get it AC coupled. However, you can add that charge controller on. So this is the Schneider 80 amp 600 volt MPPT charge controller. This is a 600 volt max input PV voltage input charge controller. So that's awesome. If it kind of feels like a string inverter, so you can go DC coupled and still have those large strings. You might be setting up a system that has one, maybe two strings with this. Definitely, it's an 80 amp DC max charge current, that's definitely enough to get those batteries inside charged up fast, and you can get up to about 4.8 kilowatts PV into this charger. With the Outback model, we utilize the Outback Radian GS48 or 8048A, excuse me. This is, again, an battery-based multi-mode inverter with an 8 kilowatts continuous capacity and a max surge of 16 kilowatts. So it's a huge inverter. It can handle a ton of surge and definitely a ton of continuous power for those heavier loads, or a large home, something like that. The 115 amps DC charger built into it, and this unit is Rule 21 compliant for California. So it can be utilized. The entire access unit is Rule 21 compliant. This one is DC coupled only right now, so you cannot AC couple this model. So it does come with two charge controllers. These are 150 max PV input, the FM80 charge controller, 80 amps DC as well. So 4 kilowatts max PV each. That means that these utilize, this Outback access unit can utilize 8 kilowatts of PV. So huge system. We can definitely do some of our larger systems with this unit, with the 8 kilowatts continuous, the max surge of 16 kilowatts, and actually being able to utilize 8 kilowatts of PV. So just kind of as a quick rundown, what's included with the Schneider unit, we're talking about either 10.5 kilowatt hours of batteries or 14 kilowatt hours of batteries. Comes with the inverter, comes with the control panel, and it comes with either the system control panel or the comm box. So it's either if you want the monitoring system or not. The optional features would be that charge controller. So again, it's AC coupled out of the box. You have to add in that charge controller. And again, that comm box for monitoring if you want it. You can also add things like automatic generator start switches to it if you want to utilize a generator. And if you even want to add more batteries, we have an optional battery cabinet where you can expand on this energy storage number. So that optional battery cabinet can fit 12 batteries in it. NEMA 3R as well. So you can get a total of 16 batteries using this unit. With the Outback, it comes standard 14 kilowatt hours, so it's a larger system. GS48 8048 multi-mode inverter comes standard. Again, DC coupled only on this one, so the 2 charge controllers do come standard. It also comes with the Mate 3S for programming and connecting to the web-based platform. So it actually comes with the monitoring capability built in. It also comes with the Hub 10 for connecting different devices together, and actually comes equipped, it's no extra cost, with an automatic generator start built into it for any 2-wire generator. The only optional feature here would be if you want to add that extra battery cabinet. Again, with those 12, you could add up to 12 extra batteries to this unit. So as far as programming goes on the Access, I mean, out of the box, you technically do not need to change any programming. It comes pre-programmed with our basic simplified settings. You might, if you've installed a couple of them, you might find that you like to change a little bit on each one depending on the mode of operation or the customer preference. So if you want to use certain features or change certain parameters like the rebulk and how high that battery stays charged, or maybe you even want to turn on some more advanced features like the cell or the peak load shaving, you can definitely get in there and change those settings. But out of the box, it is ready to go. As far as monitoring goes, depending on the system you have, so if you are working with the Schneider system, we just utilize their platform. This is the Schneider monitoring through the CommBox. You can see here you can get a data for all of your historical data and see what's been happening. And you can actually log this data either to the cloud or actually hard log it and be able to pull that data directly from the CommBox. You can also see the real-time data. This is something you can get on your cell phone and just utilize it. You can see how much solar production you're getting, where the loads are being pulled from, how much your house is actually using, how much grid, where the battery's at. Definitely a cool feature when it comes to monitoring. The Outback is about the same. So when it comes to the Outback Access, again, we can see that real-time monitoring, that historical data, as well as the Outback actually allows for you to go into device map and actually change different things. So you can actually go in and change settings as the installer, or if permission is granted to the end customer even. So those are kind of just a quick rundown of our 2 Access units. Kind of as one of our newest products, and just to kind of set the stage here, these are shipping now. They're ready to go, and that is our Express unit. So this unit is kind of a take on the Access, designed as kind of a small half unit of the Access. We actually had this at SPI. Really cool unit. So if you look on the side, there's actually 4 outlets here, including 2 USBs, and this could be for powering pretty much whatever you can think of. You can plug in a power strip and even power more than the 4 outlets out of here. You can charge your cell phone straight out of the unit. It also has the ability to plug in a PV system or any DC source that would have this DC inlet, and we can actually charge the batteries from a renewable system. We could even roll this on site and actually charge it using a PV source. You can also charge it from the AC source. So there's an AC outlet here where we can actually plug in something like shore power, or even just plug straight from the grid. So if you had a power outlet, you could take this into your garage, plug it in right into the just normal outlets, and charge up the batteries. Cool thing there is we can actually bring it. So you know, say you're in Florida or something and you just want a little bit of backup power in case maybe, say, a hurricane comes through, this unit can just be plugged in, charged up, and because of the low self-discharge rate, you can store this away until you actually need that power. Then you can roll it back out and start plugging things into it and utilizing that battery backup. So this unit currently is coming in 2 sizes. It comes in the Express 24 volt and the Express 48 volt. The biggest difference here is first and foremost the power. So we can utilize 2,000 watts continuous with this, the 24 volt model, and over 4,000 watts continuous with the 48 volt model. Actually 4.4 with the 48 volt model. So pretty heavy duty. The batteries, the 48 volt model is a 7 kilowatt hour system, and the 24 volt is a 5.4 kilowatt hour system. I would say the only other thing that's really worth mentioning here is that the 48 volt model comes in with an 120/240 output, so you can cover some really heavy loads, whereas the 24 volt model is 120 volts only on the AC side of things. These are NEMA 3R, so they're ready to go. They're outdoor rated, they're on wheels, you could wheel it around for emergency relief. Tons of different use cases when it comes to the Outback Express unit. Again, these are built up and already shipping out. So the other big one that we kind of unveiled at Solar Power International this year is our high voltage microgrid solution. So it's called the microgrid solution in this slide. I would say it's more of a commercial and industrial use. So what this is it's actually just utilizing our same small 48 volt batteries here, but we can stack up in series instead of parallel. So minimum stack would be 16 kilowatt hours, but we can scale all the way up to 2 megawatt hours. And the voltage range is actually 200 volts to 800 volts DC nominal. So we can utilize this with some larger systems, definitely utilize it with something that might be doing 480 AC 3-phase. So we could pair it up with the Ideal Power, Dynapower, those kind of bigger inverters if we're trying to build out either a microgrid or maybe we're just trying to cover like a grocery store backup. We can utilize this. So again, it's the same design. We're just using those smaller modules, but we can really customize and stack. So this unit comes in this case right here. This case is not NEMA 3R, so it's meant to be inside. However, we do have an option where you can buy, so say you had 10 of these that you were purchasing, and maybe you wanted to get up to a megawatt of power or a megawatt of energy storage, you could actually buy this in one of our pre-made shipping containers where it would ship out with the disconnects and everything built into it. The battery management system, unlike our kind of standard batteries, is actually external. So this would be the battery management system head, and it would control, this is the stack controller, and it would actually control each unit. This allows us to be able to pull units out if we need to, and everything is connected externally. Comes ready with communications, CAN bus, Modbus, Ethernet, and we can definitely utilize pretty much any of those communication protocols when we're setting up these systems. So definitely, if you're interested, if you've got some bigger projects or anything like that, let us know, and we can start kind of working out what that might look like utilizing our high voltage stacks. So I always just like to end my presentations with just a few case studies to kind of give you an idea of some ideas, I guess, better wording there, of what to utilize the Simplify batteries for, what you can utilize them for. So this is the Department of Defense. This was an older project, I believe back in 2010, where we were actually replacing lead acid batteries. So these batteries were all lead acid in the beginning, and we were just putting our lithium iron phosphate in to cut down on diesel consumption. It worked great. So this was with forward operating bases overseas. These were hot climates. They still, to this day, have never had a failure with all of the batteries that they've purchased. And we actually cut the diesel 50 to 70% diesel offset just by switching out the lead acid batteries. That's because the lithium battery can actually hold a charge so well. Residential, and this could be even off-grid in this case. So this is the governor of California. He's got our batteries on his off-grid home. So, you know, huge system. There's actually more batteries than you can see here. 3 outback inverters, and definitely safe, reliable off-grid power. I mentioned these larger systems, even beyond the high. So if we're just talking about our 48-volt batteries, not even the high voltage, we can definitely scale up way, way big. So 88 batteries in the system, 300 kilowatt hours, tons of different orientation, but this is totally fine. And we can parallel as many as we want here, and really build out these larger systems. And this is for emergency backup. So this is a large-scale emergency backup system utilizing these 48 volts. Residential grid-tied charging and backup. You know, this is a dual-purpose system. So we're talking about, you know, they wanted to charge their car, as I mentioned, definitely a big one there. So they charge up the batteries, dump all the energy into the car, and they get home. But also during the Super Bowl, they had an outage and they were actually able to use their power. So again, kind of just a dual purpose system when it comes to these DC coupled systems, of being able to also utilize it for backup. Large off-grid, again, you know, great example of some really, really critical power in this airplane hangar, utilizing these larger systems. This system actually uses bus bars, which is kind of cool. Which we also warranty. And then diesel offset. I kind of mentioned this a little bit on the Department of Defense, but you know, there's tons of places all over the world and remote areas that are still using diesel generators as the main source of electricity, whether they're replacing the diesel completely and adding PV and batteries in, or just simply trying to offset running that diesel generator as much as they can by adding batteries in. Definitely a great way to utilize our batteries. Awesome. So there's a couple questions. It looks like we might have finished a little early. So I will go ahead and just pull up the Q&A and see what we have in there. And then if anyone else has any more questions, please feel free to go ahead and type those in. So where do we buy the Magnum version? The AE said they had no access at this time. Yeah, AE is actually not one of our distributors right now. So just our distributors, we've got tons and tons of them. I would suggest maybe saying who you work with now, other than AE might be a good suggestion, but CED Green Tech has them, UMA Solar, Alti Store. I'm going to miss some and I'm going to feel bad, but Wholesale Solar, Real Good Solar, tons of different areas. If you have any trouble finding it, just let us know. But yeah, you won't find those at AE right now. And then, can the high voltage stack work with SMA Sunny Boy storage inverters, or do you use the SB storage inverter? Yeah, so the Sunny Boy storage, I actually don't know the answer to that, because the Sunny Boy storage is kind of meant for a little bit smaller design. I don't think it's necessarily meant for those larger built-out systems. So that's a good question. I mean, the smallest you could get is 16 kilowatt hours, and I'm not sure what the voltage range would be there, but likely I would say for the Sunny Boy storage, I would hold tight, and not to say too much, but I would hold tight there and say that likely that'll be a different product that we would pair up with that Sunny Boy storage, which would be smaller, but still that high voltage. But really right now with that high voltage stack, it's kind of more of those larger scale inverters that we're pairing up with. What is the historical failure rate of the Simplify 3.4? You know, I don't have those exact figures off the top of my head. Not a lot. I mean, I can tell you right now, most of the failure oftentimes is caused by poor system design and not often failed by the battery itself. So oftentimes if a system's oversized or you know, maybe the voltage set points weren't programmed right, and that's just pushed over and over again, we might see some issues. But truly, those batteries are really strong. And just a quick add on to that, those 3.4 kilowatt hour batteries. So that was actually the older model of the 3.5. Cool thing is, with our expandability of the battery, you can actually add on, if you have an existing bank of 3.4s, you can go ahead and add 3.5s to them and they can mix. So that's definitely, like, we try to hold true to that you can always expand even when we build out new products or upgrade our energy storage amount. Okay, well, it looks like those are the last questions. Let me make sure I didn't miss anything. Okay, so again, I've got a customer with a SolarEdge SE6000 AC coupled setup. So what is your solution? I'm not sure which one the SE6000 is. If that's the one that's already ready for batteries, that would be maybe a solution that I was talking about with that Sunny Boy storage that's still to come. As far as if it's just a SolarEdge system, so it's just grid-tied PV, definitely we can utilize that access unit, the Schneider access unit, where we can just run the AC power straight into the unit, and now we have backup power. So with the SolarEdge or any microinverters, we can just go ahead and AC couple to that Schneider access unit. The Magnum also can, the larger one, but we're not advertising as such just yet. So definitely right now, if you're AC coupling, utilize that Schneider access. Awesome. So he said, yeah, no, not battery ready yet. The Schneider access will work. Yep. So exactly. So and the way that works, just to kind of give you an idea, is it actually what it does, frequency shifting. So the unit itself can, first of all, automatically disconnect when it doesn't see the grid, and bring back online that, it actually brings online that SolarEdge in order for the PV to continue to produce even when the grid's down. So you kind of get 2 in 1 there. You get both the battery storage as well as you get the ability to actually bring back online that grid-tied PV even when the grid's down. Awesome. Well, it looks like all the questions here. I always send follow-ups that'll have it'll have the PowerPoint presentation in the PDF form, as well as some spec sheets of the stuff we went over. Please, 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 if you have any system design questions, ordering questions, any questions at all, it's my personal email, so feel free to shoot me back an email. I'm happy to help, and I'm definitely happy to go ahead and send, help out with system design and send information. So I see somebody's adding their email in. I will write that one down right now, but I should have everyone's emails if you registered online. So if for some reason your email address was not correct when you registered online, just go ahead and shoot me an email at Troy D, like dog, at simplifypower.com. Awesome. Well, thank you so much, everyone. I really appreciate you joining today, and look forward to some more installer trainings coming up here for our certification process. If you're ever looking for trainings or any events like that, you can pop onto our website and check out our calendar. Thank you, everyone.